Hold on tight because we're about to travel back in time. It all began millions of years ago when the famous asteroid of gigantic proportions crashed into Earth and sent non-avian dinosaurs into extinction. With the stage cleared and free of those scale and claw colossi, the mammal said, "It's our time." And so these little opportunists took over the planet, ascending to the vacant throne as if it had always belonged to them. But they didn't settle for just ruling. They started to grow and grow even more, reaching their peak about 34 million years ago in a spectacle of colossal dimensions. Back then, in the vast plains of Eurasia, a true titan emerged that left everyone's jaws on the floor: the Paraceratherium, a hornless rhinoceros that looked like something straight out of a movie. For many, this mastodon earned the title of the largest land mammal to ever walk the earth, an undisputed king that no other seemed able to dethrone. Or so it appeared. Because in the 19th century, in the mysterious and lush lands of India, a discovery shook the entire world. The remains of a prehistoric elephant, the Palaeoloxodon namadicus, came to light, and its size was so staggering that experts still debate whether this giant managed to outshine even the Paraceratherium itself, claiming the crown as the largest land mammal of all time. Get ready to meet the heavyweights of prehistory. But wait, it gets even more interesting, because the Palaeoloxodon namadicus wasn't an isolated genus, but a species within an already existing group, the Palaeoloxodon, a family of elephants that began its evolutionary journey in Africa about 4 million years ago in the early Pliocene. Among the first stars of this clan was the Palaeoloxodon reki, another titan that didn't lag behind. A fully grown male of this species could weigh over 12 tons, surpassing any modern elephant you know. And that was just the beginning. The story turns epic between 600,000 and 800,000 years ago, when a group of Palaeoloxodon reki decided to pack their trunks and migrate from Africa to Eurasia. This journey gave rise to two new species that left their mark. First, the Palaeoloxodon antiquus, an even larger elephant that tipped the scales at over 15 tons and stood taller than nearly all theropods that ever existed. Curiously, some of its descendants settled on islands in Europe and, over time, transformed into the smallest elephants ever known. What an unexpected twist for a family of giants. But the true king of this saga was the Palaeoloxodon namadicus. The oldest remains of this colossus date back more than 700,000 years to the early Middle Pleistocene, and when paleontologists uncovered its fossils, they were left speechless. A femur larger than that of a triceratops stole the show. With that bone and a right humerus, they calculated that one individual stood 4.35 meters at the shoulder. Impressive, but wait until you hear what's next. Years later, another femur surfaced, 20% larger than the previous one. This time, scientists estimated that the namadicus reached a height of 5.2 meters at the shoulder, taller than most giraffes, and weighed an astonishing 22 tons. That's a mammal in a league of its own. So, while the Paraceratherium had its moment of glory, the Palaeoloxodon namadicus came along to steal the spotlight, proving that land mammals could reach sizes that defy imagination. What do you think of this parade of giants? Nature never ceases to amaze us, does it? The Palaeoloxodon namadicus not only claimed the title of the largest land mammal of all time, but its colossal weight places it in a superior league. At around 22 tons, this titan outweighed the Spinosaurus, the Giganotosaurus, and even the fearsome Tyrannosaurus rex. But it doesn't stop there. It surpassed the mass of all non-sauropod dinosaurs that ever existed, and even left some sauropods behind, a size so immense it seems like something out of a dream. Are you enjoying what you're watching? If so, consider subscribing to the channel. It really helps me keep creating content like this for you. It costs you nothing, and it motivates me a lot to keep making more videos. So if you want to support the channel, go ahead and subscribe, and don't forget to hit the bell so you don't miss anything. This staggering volume, which we can hardly fathom, raises a question. Just how far could land mammals go in terms of size? Imagine a world where giants didn't just walk, but shook the earth with every step. Yet despite these estimates, not all paleontologists agree that the namadicus reached 22 tons. Some have questioned this figure, pointing out that the available fossil remains are fragmented and don't allow for a complete skeletal reconstruction. The bones found, though impressive, often consist of isolated pieces like femurs, humeri, or cranial fragments, making it difficult to determine the animal's total size with precision. This uncertainty also affects the Paraceratherium, whose fossils present similar preservation challenges. The lack of complete skeletons has kept the controversy alive over which of the two was the largest land mammal, a debate that has sparked numerous studies and discussions in the scientific community. In 2023, a team of researchers attempted to settle this mystery by analyzing a more complete specimen of the namadicus, which they dubbed CF Palaeoloxodon namadicus. The initials CF stand for compared with, as they weren't 100% certain it was definitively the exact species, given how challenging the discovered remains made identification. Even so, after a detailed examination, they concluded that its weight likely ranged between 18 and 19 tons, while the Paraceratherium was estimated at around 17 tons. These new figures, based on a more thorough analysis, have led many experts to lean toward the namadicus as the winner of this comparison, though the absence of complete skeletons continues to leave room for doubt. Even with this adjustment, the namadicus vastly outstripped modern African savanna elephants, which averaged between 6 and 7 tons and was about 300 times heavier than an average human weighing 65 kilograms, giving a clear sense of its magnitude compared to present-day life forms. The physical characteristics of the Palaeoloxodon namadicus were as remarkable as its size. Its skull, dense and sturdy, was designed to support a head of considerable proportions, a structure that reflected its adaptation to a massive body. At the top of the skull, it featured a prominent bony crest that served as an anchor point for strong muscles, essential for moving such a large and heavy head. This cranial robustness also enabled it to handle tusks that, according to paleontologists' estimates, could reach up to 5 meters in length, making them the longest tusks known in the animal kingdom. These tusks, likely straight or with a slight curve similar to those of the antiquus, gave it a remarkable ability to maneuver, allowing it to lower its head to the ground without losing balance while feeding or interacting with its environment. The namadicus's molars, analyzed for their shape and wear patterns, revealed that its diet consisted mainly of low-lying grasses, an abundant food source in the plains and savannas where it lived. It's estimated that it consumed around 150,000 calories daily, a quantity that doubles the 70,000 calories a modern elephant needs to sustain itself, reflecting the enormous energy demands of a species of such dimensions. This grass-based diet required the namadicus to spend much of its time feeding, roaming vast expanses of terrain in search of enough vegetation to support its body. Despite spending so much time feeding, the namadicus was not an easy target for the predators of its era. Its imposing size, combined with thick, resilient skin, made it virtually immune to attacks from animals like saber-toothed tigers, prehistoric lions, or large crocodiles, which inhabited the same regions but posed no significant threat to healthy adult individuals. The namadicus's body structure, with robust legs and a massive torso, provided stability that made it a formidable opponent, even for the largest carnivores of its time. However, humans did play a role in its story. In various archaeological sites, the remains of the namadicus have been found alongside stone tools, such as spearheads and knives, as well as evidence of campfires, indicating interaction with our species. Although there's no conclusive proof that it was systematically hunted, it's likely that humans took advantage of its remains after natural deaths, using the meat, bones, and skin for various purposes. In some cases, it's also possible that they confronted it directly, particularly targeting young or weakened individuals. This relationship is also observed in other species of the genus, such as the antiquus and the reki, whose fossils bear cut marks and fractures suggesting butchering activities by human groups, a practice that became more widespread as human populations developed more advanced hunting techniques. The range of the Palaeoloxodon namadicus was vast, stretching from India, where most of its fossils have been found, to southern China, and including regions like Malaysia, Myanmar, Laos, and Vietnam. This wide geographical presence demonstrates its ability to adapt to a variety of environments, from open plains and savannas to areas with denser vegetation, such as tropical and subtropical forests. The Indian subcontinent, with its warm and humid climate during the Pleistocene, provided ideal conditions to sustain a population of elephants of this size, with an abundance of grasses, nuts, and water. Further east, in Southeast Asia, the namadicus also found suitable habitats. enabling its expansion across thousands of kilometers. A notable case occurred in Japan, where its descendants arrived via land bridges formed during periods of lowered sea levels, such as those connecting the Asian continent to the Japanese islands tens of thousands of years ago. In this insular environment, the namadicus underwent a reduction in size, reaching roughly half its original dimensions, an adaptation to island life similar to that observed in the Antiquus on Mediterranean islands. Despite this downsizing, these elephants remained remarkable and left behind a fossil record that has allowed paleontologists to reconstruct part of their evolutionary and geographical history. The namadicus lived in organized herds, a behavior it likely shared with other species of the Palaeoloxodon genus, and one that resembles that of modern elephants. In these groups, adults formed a protective barrier around the young, offering security against potential threats, whether from predators or harsh environmental conditions. This social structure not only provided a defensive advantage, but also enhanced survival in a competitive environment, allowing the calves to grow under the protection of the group's strongest members. Furthermore, it's reasonable to assume that the namadicus possessed intelligence comparable to that of modern elephants, which are known for their ability to solve problems, recall past experiences, and maintain complex social bonds. This intelligence would have been a key tool for avoiding dangers, including human hunting attempts. Fossils of this genus, including those of the namadicus, show evidence of human intervention, such as cut marks and fractures on the bones, pointing to the use of spears, thrown stones, or traps. These techniques, developed by our ancestors during the Pleistocene, enabled them to confront the era's megafauna with some success, though hunting a fully grown namadicus in prime condition must have been an extremely challenging task, perhaps reserved for well-coordinated and equipped groups. The extinction of the Palaeoloxodon namadicus occurred between 40,000 and 50,000 years ago, a relatively recent period on the geological scale that coincides with the end of the Pleistocene. The primary cause of its disappearance appears to have been a climatic cooling that disrupted the ecosystems it relied upon. This change, known as part of the climate fluctuations during the last glaciation, transformed the forests and plains where the namadicus lived, reducing the availability of grasses, which were its primary food source. Given that it needed to consume vast amounts of vegetation to sustain its body, as we discussed earlier, this scarcity would have significantly weakened its populations, limiting their ability to reproduce and survive. Additionally, human presence may have contributed to its decline. Modern humans, known as Homo sapiens, arrived in the regions inhabited by the namadicus about 30,000 years before its extinction, bringing with them a set of skills and tools that included projectile weapons, such as spears and traps. These innovations would have enabled hunters to target these elephants more effectively, particularly vulnerable individuals like calves, pregnant females, or sick specimens. The decline of the namadicus was not an isolated case. Other large species of the time, such as the stegodon, a related elephant with distinctive tusks that inhabited Asia, a prehistoric oversized hippopotamus that lived in rivers and lakes, and an extinct horse with a striped pattern reminiscent of modern zebras, also vanished within a similar time frame. This coincidence suggests that a combination of climatic factors and human pressure was responsible for the extinction of these megafauna forms, marking the end of an era in which land mammals reached extraordinary sizes. Although the namadicus no longer exists, its legacy endures in its modern relatives and in the fossil record that continues to be studied by scientists. The African savanna elephant, known for its size and imposing presence on the plains of Africa, shares a common ancestor with the Palaeoloxodon genus, making it a distant echo of these prehistoric giants. However, it is the African forest elephant that offers a more direct and fascinating connection. Studies of mitochondrial DNA, which analyze genetic material passed down through the maternal line, have revealed that this species is more closely related to Palaeoloxodon than to the savanna elephant, suggesting it preserves part of the namadicus's genetic lineage. This genetic link is a living bridge to the past, indicating that the evolutionary impact of this prehistoric elephant was not entirely lost with its extinction. Some researchers speculate that under the right conditions, such as an increase in resource availability or changes in ecosystems, evolution could give rise to new forms of large-sized elephants in the future, though this remains a hypothesis that would require thousands or millions of years to verify. The fossils of the Palaeoloxodon namadicus remain a valuable source of information for paleontologists and other scientists interested in the history of land mammals. Each new discovery, whether a long tusk evidencing its ability to manipulate its environment or a well-preserved skull revealing details of its anatomy, provides insights into the characteristics and lifestyle of this species. These findings confirm that the namadicus was an exceptional land mammal, defined by its massive size, its capacity to consume vast amounts of food, and an intelligence that set it apart in its environment. Its presence dominated the regions it inhabited, from India to Southeast Asia, leaving an indelible mark on the history of mammals that spanned hundreds of thousands of years. Paleontologists continue to study its remains to better understand how these giants evolved, what factors led them to reach such dimensions, and what circumstances drove them to extinction. This effort not only keeps the namadicus' story alive, but also sheds light on the evolutionary and ecological processes that have shaped the modern world, reminding us of the complexity and fragility of life on Earth.